Okay, so we're looking at the second year Stats and Mechanics textbook. We're doing chapter 6, which is on projectiles, and we're looking at exercise 6b, which is focusing on the horizontal and vertical components. So we're on question 5, and this is different to the previous 4 questions, because this time they're giving us the velocity as a vector and asking us to work back to the actual initial speed and the angle it was projected at. So there are no problems with that. So basically 6i plus 9j means 6 to the right, so that's the I part of the vector, and 9 up. Okay, so that's going to be the actual the way that the particle is actually traveling initially. So they want to know the angle it was at. So now I've got that drawn out, you can see that it really is pretty straightforward, because that's going to be a right angle triangle, because this is vertical, sorry, that's horizontal even, and that's vertical, so they will be perpendicular to each other. So it's just a simple right angle triangle. I've got the opposite and adjacent sides, so I'm going to use tan. So tan of alpha is opposite, sorry, I said alpha and theta. Tan of theta is opposite over adjacent, so theta is inverse tan of 9 over 6. Let's just stick that to my calculator. And I'm getting that to be 56.3 degrees. So I've actually answered the second bit first. So that's the angle of projection. Okay. Then I also need the initial speed. So by that they mean the speed it's traveling in that direction. So that's even simpler. That's just Pythagoras. So that is just going to be, so let's call that u. So, well, u squared would be 6 squared plus 9 squared. So u squared, let's be lazy and stick that to a calculator. So u squared is 117. So that initial speed is root of that. So 10.8. Oh, tweet. 10.8 meters per second to the -1. Okay, it's just I think so initial speed. So there's our initial speed, and there's the angle of projection. Let's just double check those. 10.8 and 56.3.